I will try to explain how the program I have developed for uh, finite element analysis of lattice structure works and how the two components from MATLAB and COMSOL interact. So I'll try it by us launching this application. During the first time, it asks for a username and a password which one has to create, and I don't think they are ever used after that. So one can set any password they want. So this is the main file. I am first defining the geometric parameters here, and these are the number of sample points for each curve that I will create. So this function creates those curves and stores them in these arrays. Horizontal 1 corresponds to horizontal curves with a positive offset, then horizontal 2 is with negative offset, and similarly for vertical 1 and vertical 2. So I can plot them by this flag. If I run this, so this is the functional form of theta thickness I have given. I can change it. Let me turn off this. Now it will be a constant. Here it is, constant thickness. I can do something like this. For this particular function, it is more bulky, far from the origin. So this is the origin, center of the lattice. Now from here, this is the function to generate the COMSOL model. So these here are the variables that COMSOL will require. These many. I'm passing these. Like for example, these are required to create geometry. These are the three material parameters. Then mesh control. Then time of the simulation. This is the load, and these are the geometric parameters. I'll go through this file so I can turn it off actually. I'll go through this file step by step. So this is simply a MATLAB function. This is some initialization required, like creating the file name and label for it. and these are the parameters I'm passing. Wait. Let's see. I can launch this using this. This will launch the corresponding COMSOL file that this particular function is working on. So here it is. Right now the name is simply untitled, and whatever this function will do step by step, it will be mirrored in this file. For instance, until now the only thing that has been done in the file is creating these parameters. So it has created those, and now it will create a component. This 2 indicates a 2D component and the default mesh. So here the component, through these through this function I'm creating the horizontal curves. So I'll just do this. Now if I go to geometry, this group is also something I have created through this. After creating, I'm adding these curves to this particular group. So if I do build all, this created these horizontal curves, and similarly there is one loop for vertical curves. This one. If I again do build all, we generate this. Now how do I know that I require these things specifically to generate my required curves? So for that, the thing I do is first I create a single curve in COMSOL using its GUI. Then for example, let's say I've created one curve. Let's say I delete this. Let's say this is the only curve I have created. So first thing I need to do is compact history. It will give this thing. Then save as. I can save it as an M file. I'll give it temp.m. It will come here. Now by looking into this file, I can see that this is the line required to create this particular node. To create this node, then to put a label on it, and this is where I have set the values, and then to add it to group 1 through this. So by looking into this, essentially I have uh, made it in a loop, made it go in a loop. This thing I have already created from, I'm already passing to it through this function. Okay, I'll run it again because I had created those curves. Okay. Right now the file is empty. Not empty, it has the parameters. That's it. Now I'll do this. So it has the horizontal curves now. Then the vertical curves. Build on. Now I need to join these ends, this and this. Similarly, this and this and so on. So this is creating groups for. Actually, this is the group for. Uh, this is called line segments in COMSOL. So I'll run this one. So it will. I'll do build all. It has gone there. Build all and it joins these two. Now again, this part will join these two here. Build all like this. Next, I need to take these four, this, and this, and make a solid out of it. So for this, I'm first selecting all these four. These are coming from here. Tag one, tag two, then these two, and creating a solid out of it. If I do build on, if I go there, so this has become a solid body. Now I need to do this again and again. Let's see. So now it has done the same thing for all these. If I do build now for the vertical ones, horizontal ones, build all these. This will basically these two lines are required to do this thing build all. That's it. It will create and by default all these individual bodies are connected by union. So union is basically taking a boolean sum of all these bodies. So now it has become a one combined body. Now it will create a new material. The material comes here. This is the material. Right now there are no parameters in it. I have added them later. Then this adds the physics solid mechanics to geometry 1, geom 1. Next, these, okay, so this is the IDs of the edges where the force boundary condition is imposed. Can show them. Yeah, this will create the boundary load node, and this will set them to these edges. So this is 60 till 20. These are the ones. Then these are the fixed ones. But 2 to 5, these ones. Then this is for creating mesh with this mesh size, which is a parameter from. This is some default view for COMSOL. Here I am setting the values of the parameters. This allows physics symbols, so the boundary condition will be more easily visible. These are fixed, and here I have applied a loop. This is the thickness of the structure. D is the internal variable, and B is what I have given COMSOL. This D is the beam thickness. This B is the out of plane width, which I am setting here. This thing is specifying what the value of load is. So this will increase with time. It is not set it yet. So it will increase with time. But the formulation itself is quadratic. Time has no effect on the equation, but it will just act as a parameter so that I can increase the load slowly instead of giving a total load at once. So this will create the steady and the steady and transient steady, as I mentioned. This step this step is to run it. Okay, this is the range for which I want to run the simulation. So do if I go over this, we'll run the simulation. After that, it is plotting it and then to saving it to a specified file, which I have given the name model. This. So it has computed the solution. I'll show it. Or I can show from. Now here's the plot. Okay, make it at the end. So this black outline is the undeformed one, and this is the deformed configuration. Now, before saving the file, I can store some data like stress value or the displacement of a particular point, like maybe this point, something like this. So it has created this model file. I'll just do this. Now I can run this thing for any function, for any choice of this function. And I think next thing will be to account for the plasticity of the material by choosing a suitable elastoplastic law.